Welcome to Ask and Learn.
So this is the diagram. So here we are going to split this into two parts. This is the wheel with center E, and this is a ABCD part. And now we will draw two free body diagrams for the wheel and for the ABCD part separately. And let's do the problem. So let's start by drawing the free body diagram of the wheel. This looks like the free body diagram of the wheel, where M is the moment, E is the center point, and the radius is given in the question itself. It's 150 mm, and we resolve the center point E along x-axis as EX and along y-axis as EY. And we calculated the value of beta. It's 3 pi by 2. It's to 70 degree, and consider a counterclockwise rotation creates a tension, and we name that tension as TB. And also consider the clockwise rotation creates a tension, and we name that tension as TA. So now we know the relationship between TA and TB, that is TB equal to TA into e raised to mu s beta. TB equal to TA into e raised to mu s beta. And from the question, the value of mu s is given as 0.25, and from free body diagram, we found beta is 3 pi by 2, that is 1.5 pi, that is 270 degree. So let's substitute the value of mu s and beta in the equation. So that gives TB equal to TA into e raised to mu s into beta, that is mu s is 0.25 into 1.5 pi. So let's calculate the value, and we got it as e raised to 0.25 into 1.5 beta is 3.248. That gives TB equal to TA into 3.248. Let's name this as equation number 1. Now we are going to equate the moments about the center point E. We already talked the center point of the wheel is named as E. So let's equate some moment M at the center point E. So that will give us summation of ME equal to 0. So let's solve this. Summation of ME equal to 0. Yeah, summation. Sorry. Yeah, that is summation of ME equal to 0. That gives us minus M plus, let's convert all the millimeter value into meter. That is, the 150 millimeter will be equal to 0.150. So 0.150 TB minus 0.150 TA equal to 0. So Let's name this as equation number 2, and let's substitute the value of TB from equation number 1 into equation number 2. So 1 on 2 gives us minus m plus 0.150 into TB is 3.248 times TA minus 0.150 TA equal to 0. Solving this will give us m equal to 0.3372 TA, 0.3372 times TA. So that is TA will be equal to m divided by 0.3372, that is 2.965, 2.965 times m. Let's name this as equation number 3. So we got an equation of TA in terms of m. Now let's replace the value of TA in this equation number 3 using the value from the equation number 1. So let's do that. That will give us TB equal to 3.248 times 2.965 m. That is 9.632 m. 632 m. Let's name this as equation number 4. So now we are going to draw the free body diagram of ABCD bar. This looks like the free body diagram of ABCD bar. So yeah, and let's all the other values are given in the question itself. The 80 mm, 320 mm, and the 100 Newton. Everything is given in the question itself. The values are given, and we resolve the C along x-axis as Cx and along y-axis as Cy. Now let's equate the moments about point C. That gives us summation moment C equal to 0. That is just like before. Let's convert every millimeter value into meter. Let's standardize every values. So the 80 mm will be 0.08, that is 0.08 times TA plus 0.08 times TB minus 100 Newton times 0.320 equal to 0. Let's take 0.08 common outside. that is 0.08 times TA plus TB, and 100 into 320 is 32, and this minus, when this term will go, the right hand side of the equation will changes to plus, and that is equal to 32. Let's name this as equation number 5. So let's substitute the value we got from equation number 3, the value of TA, and from equation number 4, the value of TB in terms of M. Let's substitute all these values in equation number 5. Let's do that. Yeah, so 3 and 4 in equation number 5 gives us 0.08 TA is 2.965 m, and TB we got as 9.632 m, which is equal to 32. Let's solve this and we will get 1.007 m equal to 32. That is m equal to 32 divided by 1.007. That gives us 31.7535. 7535 and Newton meter. So we got the value of m. So now the other part of question is, if the rotation gets changed, what will happen? So even if the wheel rotates in counterclockwise direction, then the only change will be the tension will get swapped. That is, when the rotation is in clockwise, let's call the tension TB. Then if the rotation is in counterclockwise, then the tension will be TA. That is, the new TA will be the old TB when the rotation is in clockwise, and the new TB will be the old TA when the rotation is in clockwise. But yeah, let's take the sum of these. That is TA plus TB equal to TB clockwise plus TA clockwise. So here we can see the sum doesn't change. Only the values get swapped when the rotation changes. So we know that the couple M is a function of sum of tensions. That is, couple M is a kind of function that is the sum of tensions. So here the sum is constant. We just proved the sum is constant. So that means the swapping or the change in rotation doesn't affect M, and therefore the M will remain same for clockwise and counterclockwise direction also. Even if we change the rotation, the only thing going to happen is just swapping the values of tension. The M value will get remain constant as the sum remain constant. So let's find MC, that is TA plus TB will be 400 Newton, and TA is, we know it's 2.965 into M, and we calculated the values of M. The value of M is 31.7535, so TA will be 2.965 times M. M we calculated as 31.7535. That gives us 94.1491 Newton. So we got the value of TA. Now let's calculate the value of TB. TB is 9.632 times M. M we calculated as 31.7535. So this calculated value is 305.8497 Newton. Let's calculate the torque at point C also. The torque at point C will be the difference between torques into radius. That is TB minus TA times R. We now know every values. Just substitute, and we will get it as 31.7550 Newton meter. I think you understood the problem. Thank you.